In this lesson, we're going to look at how we classify organisms. So what we used to do was classify them based on habitat or structural similarities. And there was a lot of problems with this. What do we do with these? Do we classify this with the land-based turtles or with the ocean-based fish? What do we do with mushrooms? And so, as time has gone on, we've discovered a lot of new organisms. We've learned a lot of new things and created a lot of new technologies, especially genetics, learning about genetics and evolution, and then creating technologies whereby we can compare DNA, like DNA fingerprints, which we'll look at here in a minute. So nowadays we classify organisms by common ancestry. Another way to think about this is evolutionary relatedness. So how related are they evolutionarily? And what we're going to do is, based on this, we're going to put them into taxonomic groups. And these are simply classification groups. So nowadays what we would do is classify this whale with a cow and not with a whale shark, because the whale and cow are mammals and are more closely related evolutionarily than they are to a fish. So let's look at the different taxonomic groups. These are the 8 groups, and I think of it like an inverted triangle. So as you go down the list, you get fewer species and individuals are more and more related. So once you get down to species, everybody is very related. When you're at domain, however, they have a lot more species, but they're much less related. And we'll see how this works here shortly. So again, here's our 8 taxonomic groups, or classification groups. And we're really going to focus in on the genus and the species, because this gives an organism its scientific name. So for example, the scientific name of a human being is Homo sapiens. Homo represents the genus, and sapiens represents the species. So again, our scientific names are the genus followed by the species. We're always going to write this in italics. We're going to capitalize the genus. The species is going to be in lowercase. And one of the ways that I think about this is kind of like names. So Homo, which is the genus, is kind of like your last name, because it encompasses a number of other people. Whereas the species name, in this case sapiens, is like your first name. It's only you. So while there are other species in the genus Homo, it's only humans that have the species sapiens. So let's look at kind of how this works. So we're going to look at the classifications of humans and see how, as we go down the list, we get more and more related. So we're in the kingdom Animalia, but so are sponges. So we're obviously not very related to those. Okay, we're getting a little bit closer. We're mammals, just like rats. We're primates, kind of like this lemur. We're in the family Hominidae, like this orangutan. We're in the genus Homo, similar to Homo erectus. So we're starting to see a much more similar structure. And then finally, we're in the species Sapiens. So as we went down that list, there were fewer and fewer species, and they were more and more related. Some other ways that we can look at how things are related are with like a DNA fingerprint. We can compare DNA. So when we look at this DNA fingerprint, right off the bat, we can tell the coyote is definitely not that related. The lynx and the puma are kind of related, but the lynx and the bobcat are the most related because they have the most similar DNA. Another way to look at this is with the taxonomic groups. So as we go down the list, the more groups you have in common, the more related you are. So as you can see, we're the same in all of these groups until right here. The lynx, puma, and bobcat are all felines, whereas the coyote is a canine. So it is definitely the least related. The lynx and the bobcat are both in the same genus, unlike the puma, and then they're in different species. Now, we're going to use a special thing to show relatedness called a phylogenetic tree. And basically what this is a family tree for species that shows all the different common ancestors and how the evolutionary process has occurred. So here's an example of a phylogenetic tree. These species A through G on the top, these are currently living species. And every time that there's a split, that is where two species have diverged. In other words, this is their last common ancestor. As we go down the list, we get older. And so let's look at F and G. All right, all these species before this split are common ancestors, ancestors that they shared. At the divergence, that's the last common ancestor, and then they went in different evolutionary directions. Now, to figure out who's the most related, what we'll do is we'll look at which species diverged the most recently. So which one have the most recent common ancestor? And that would be D and E, because they split closest to the current time. Whereas A and G are the least related because they split the most distantly. So if we look at our taxonomic chart, we can see the same kind of thing. The coyote was different first, followed by the puma, and then the lynx and the bobcat. So if we turn this into a phylogenetic tree, the first divergence was with the canines and the felines, and that became the coyote. The next was between the puma and the lynx. That became the puma. And then the last one was between the lynx and the bobcat. Now, finally, let's look at how we identify organisms. And we're going to use what's called a dichotomous key. And this is going to use various characteristics to help you identify specific species. And it's going to use a this or that model, which we'll see here in a second. So here's an example of a dichotomous key. So let's look at how this works. Let's say we're trying to identify species number 2. We're going to start with number 1. Now, is this an organism with 2 or 4 legs or one without 2 or 4 legs? Well, it's a plant, so obviously it doesn't have legs, and so it tells us go to number 3. We go to number 3 and it says unicellular or multicellular. Obviously, this is a multicellular organism, so we go to 5. Heterotrophic or autotrophic, it's a plant, so it's an autotroph. So we go to 7. And then it's either a tree or an herb. This is definitely not a tree. So that is the particular species. And we can do this for any of these species to try and figure this out. All you got to do is just follow the list and decide, is it this or that?